Marco Antonio Joven Romero, and I am a student at the National University of Distant Education in Spain, UNED. And I will talk about my project for the subject, or my activity number 6 for the subject Scientific English, which is gonna be the mathematical value of life, from high school mathematics to decision theory, and also applying mathematics to philosophical issues. So the basic idea of this talk is that we normally assume that life has an infinite value, but in some extreme situations we need to dedicate or to give some funding to certain activities and to certain tools to save our lives. And that's what has happened recently during the COVID pandemic. In other words, in these situations we realize that life cannot have an infinite value because we need to dedicate money to it, and we have not an infinite source of money. Here what I want to do is to apply the utility function framework taken from decision theory together with some essential mathematical tools learned in high school, and actually with some philosophical and also with some other philosophical knowledge we are supposed to learn during high school. Just not for the reasoning, but for the consequences and to analyze the topic. So, here I introduce the mathematical reasoning behind this talk. We have some parameters: V, the value of life; T, the total number of people in a population; P, the effectiveness of the vaccine. We are going to take the vaccine as the specific tool that costs money but saves lives at the same time, but we can talk also about some other things like hospital improvements, but I will explain that later. We have also parameter X, which is the number of people dead in case the vaccine is not administered. We need to do some study there to find out X. And then we have X something that refers to some specific number of people. So for instance, XS is the people vaccinated. In general, X plus number XP is just a specific number of people according to different factors or subparameters. And then we have C. C is the cost of the vaccine. So the total cost of the vaccine for the whole population would be C plus T. So we apply the utility function for a group, which is a utility function of XP is the value of life plus multiplied by the number of people who got the vaccine. Yep. It's quite easy, but be careful. If we are talking about the number of people alive, we take it positively. If we are talking about the number of people dead, then it is negative. And then we have the utility function for the vaccine. This is just I took the decision theory approach, which is the probability of being saved by the vaccine plus the utility function of these people saved minus the probability of not being saved by the vaccine plus the difference between the people who are dead, who are supposed to be dead if the vaccine is not administered, minus the people who already took the vaccine. So in these ways we have the number of people who die even when the vaccine is administered. Yeah. The reasoning is to consider the difference between the utility of the vaccine and the cost of the vaccine for the whole population, and it must be higher than the utility of not administering the vaccine. So in other words, the reasoning is that the whole administrating the vaccine, the whole utility of administrating the vaccine minus the cost of the vaccine is higher than the utility of not administrating the vaccine. And if we apply that reasoning, we finally get this equation here that I will explain in more detail in the next slide. So Here we have the final inequation. We finally have inequality, and this inequality gives us some clues. First, the more the value of a human life, then the more we assume or we are ready to pay for the vaccine. And something similar happens with the effectiveness of the vaccine, P, with the number of saved lives, XS, or even with the number of people who die if the vaccine is not administered, X. Actually, these XS and X, they are firmly related. But on the contrary, the higher the number of the total population, T, then the less the cost we can assume for a vaccine. That's normal. If we have to apply or to buy vaccines for a very, very huge number of population, the total cost is higher. But what is interesting here from a philosophical and mathematical point of view, for both points of view, is that our resources are limited. So we cannot assume an infinite number for C plus T, an infinite number of money, endless money to buy vaccines, because our resources are limited. So this approach I have already introduced has some limitations. First of all, we consider parameters, but some of these parameters are not constants. They evolve and they change according to some other parameters. For instance, the value of human life is not the same for every person. Children are more valuable than elderly people. Yeah, if we focus on the Titanic disaster, they try to save children before major men, for instance, because the value associated to each person is different, at least according to the age. Also, we are talking about the effectiveness of the vaccine P as a constant, but it changes over the time. So we need to make this basic equation a bit more complicated in order to have a better result. Furthermore, here we are only considering the cost of the vaccine, but according to the pandemic or other catastrophic events, there are much more costs associated, like new hospital facilities, personnel, and so on, and that implies more money. So that makes the equation more complicated. Even if it is basically the same idea, it would introduce new parameters and subparameters. But finally, what we are doing here is to apply basic mathematical tools we learned at high school, but we are applying at the same time new mathematical tools that we have learned in probability theory and especially in decision theory subjects. And at the same time, we face in a mathematical way a philosophical dilemma about the value of life. So thank you very much for listening to me. I hope you enjoy this presentation.